Hello and welcome back to the next tutorial. This time we make collision happening. And in order to do so, we have to do a bit of groundwork. So this is going to be a change in how entities are going to be represented in the game. Make sure that you're on the correct branch. 12 collision. Link will be in the description. We start off in the game.cpp file and we remove the transform. In order to properly do collision, we have to have a single origin point around each entity. This origin point, vector2 origin, is the position of the entity. And everything else, like the bounding box or the sprite offset, is relative to this origin. So when we change the position of the entity, everything changes relative to it. And since we removed the transform, make sure that you also put in the UN32T material index. The entity will now reference it directly. And as I alluded to earlier, we need a vec2 sprite offset. This is the position where the sprite will be drawn from. And we need what is called a Rect bounding box. This bounding box is going to be the rectangle that we use in collision detection. It's going to be placed again relative to the origin. We don't have a rect yet, so we go to mymath.h. At the top below the, let's say, vec2, we do a struct rect, and this is going to be a union. This union will hold a vec2 position and a vec2 offset. I like doing it this way because now we can refer to the rectangle as an offset or as a position. It can be a disconnected rectangle, but it can also be relative to something else. And therefore I put the offset in here too. And we have a vec2 of size. That's it. Go back to the game and now our entity has changed, which is good. Now obviously we have a bunch of errors and the next thing we need to change is the create entity. There's no longer a transform. So remove the transform from the create entity function. And I suppose we can do this over multiple lines. We need a vec2 origin. We need a vec2 sprite offset like this and a rect bounding box. Next we need to assign them. The bounding box is the bounding box, and I suppose we can do this in order. The E origin is the origin, and forgot the sprite offset will be the sprite offset. Put a semicolon after origin, and that should be fine. Okay, after that we change the init function down there. There's already a bunch of errors. When we create an entity, we now need to supply the origin, bounding box, and offset. And since these values here are hard-coded, I would like to move them into the asset system. So we can extract this, open the assets.cpp file, and below get asset we create a new function that returns a vec2 get texture size, and that only takes in an asset type ID type. And let's paste those in here. Let me center this as well, and the only thing it does is another switch on the type, and I suppose we can copy those here and paste them in here. White returns us a vec2 that is 1 by 1. The ball returns 50.0f by 50.0f. And the pedal returns 50.0f by 100.0f. Fix the type here. Okay, so this get texture size will be helpful in the game function. But before we can access this, we need to expose it. So go to assets.h. Down below where we have the const char pointer, get asset. We also have a vec2 get texture size, asset type ID, and I suppose we can do asset type ID. Quickly change back to CPP and change this to asset type ID, and here too. Also, I forgot to delete these floats, lol. And change the type here, asset type ID. Better. Now it complains because it doesn't know the vector2. So we need to include mymath.h. That should fix the errors. Yep, it does. And now back in game.cpp, we can finally get the vec2 ball size. That would be get texture size of the asset sprite ball. And we have a vec2 pedal size. That would be get texture size asset sprite pedal, like so. I also would like to calculate the offsets, and for this simple case I'll just take half the size, meaning the vec2 right offset pedal would be the pedal size divided by 2.0f and times minus 1.0f. Because the offset is, remember, y is 0 at the top and a greater value at the bottom. We need to offset by supplying negative values. So since we don't have a division declared as a operator on the vector, we need to do so. So go back to mymath.h and declare an operator, vec2 operator, and division takes in a float scalar, and it returns a vec2 of x divided by scalar and y divided by scalar. I misspelled scalar. Scalar, like so. That would be the first operator to define, and that should be okay. Now we also need a multiplication operator. And so define one like this. We multiply with a scalar 2. So now we have the sprite offset for the pedal, and then we also create a vec2 sprite offset for the ball. That would be the ball size, you guessed it, divided by 2 times minus 1.0f and semicolon. Now when we create the left pedal, we need to supply different values here. After the game state, we need an origin. The left pedal should be 10.0f padding on the left plus pedal size dot x divided by 2. This is where I'm going to place it. And the sprite offset, we have that already, sprite offset pedal. And the bounding box is a bit different. It's the sprite offset pedal again, but also the size of the pedal. That's the bounding box. Then we add the component left pedal, and the material index is no longer stored in the transform, but on the entity directly. And so I'm going to do this for all of these entities real quick. Actually, I forgot. This is just the X position here. We need to supply the Y position. And I would love to use the input screen size dot Y and divide that by 2. Place it in the middle. So I would love to take in the input here. Input date pointer input. So I can access this variable. Put that in half the screen. Let's label those left pedal, now the right pedal. Where do I put this? I would love to put it on the input screen size dot y x, minus 10 for the padding, and then also minus the pedal size on x divided by 2. So that should give it a padding of 10 pixels to the right. And on y, I would also love to put this on the input screen size divided by 2.0f. That's for the origin. Next would be the sprite offset. That would be the same thing. Sprite offset pedal, and the bounding box is sprite offset pedal and the pedal size. Anything I forgot? Oh, whoa, I figured it out. This has to be a Y. Okay, so this is the right pedal, and also remove the material index here. Okay, remove. And then the last one is the ball. We create the ball. I would guess, let's say we create the ball in the middle of the screen. So input screen size divided by 2. And then the sprite offset would be the sprite offset ball, and the bounding box is sprite offset ball and ball size. Very simple. Remove the transform, and that should be it. Let me double check here. The velocity, I put this to 0 on Y for now, because I want to increase the speed of the ball to later check if our bounding boxes and the collision works properly. So I can speed up the ball on the X position very fast and make it bounce. You'll see what I mean. Okay, that should be the init function. And next we need to change update game. Confine pedal to screen. Since we no longer have a transform, we now need to confine the origin. And the origin .y only. Since the origin is in the middle, we need to add the bottom and top padding when clamping the values. So we clamp the origin .y, not between 0, but between, well, half the size of the bounding box. So we need to add to the origin half the size of the e bounding box.size.y divided by 2. And origin.y, obviously. Let's break this into multiple lines. This would be the first one, and the second one, well, the origin can't be greater than input screen size.y minus the bounding box.size.y divided by 2. Again, half the bounding box on padding on the top and on the bottom. Okay, next we go to the ball. We need to remove every transform with origin. Well, it can't be greater than the screen size on X if we add in the e bounding box.size.x divided by 2. But not only that, because we need to know where the bounding box is. Technically, this would work if we were to change the bounding box offset to something else other than the exact half of the size of the texture. Then we would need to do a better calculation here. We would add in the e bounding box.offset, and then we don't take half the size, but we take the full size. So we take the origin plus the offset, let's say on X here, and the size, and we make sure that this is clamped, that this is as far as we can go. Now for the penetration that we need to revert when we are out of bounds, first of all, change this to origin.x. We need to invert twice the penetration. And that is the same calculation as before. We take in the origin, the offset, and the size, and we remove the screen size. The second case is when we are below 0. That would be the origin on X plus the e bounding box.offset.x. If that is less than 0, then we just need to invert the penetration again. So we need to invert what we calculated above. That's very simple to do here. You can just copy these. This is the penetration, paste that in here, and then invert it for the less than 0 case. Origin.x. Wait 1 second. Semicolon here. I'm going to do the same thing. Copy and paste. Okay, so the only thing we need to do is change x and y. Every single x needs to be changed to a y. No mistakes. Every single x has to be a y. Yep, that one too, and that one too. Y here and the last one y. If I did everything correct, that works. And I suppose for the ball, we add in the velocity to the origin times the delta time. Oh yeah, oops, origin.x and origin.y. Now there's still an issue in the renderer. We need to change that too. First of all, the Win32 platform needs the input. So go to Win32 platform, change that to input in the main function here. Supply the address of the input here. And then in the renderer, there's going to be a couple of issues. We no longer get the material based on the transform, but on the entity. And we no longer have a transform. But that's no issue. We're just going to create it here. Transform t is initialized to 0. And then we assign that. T dot. We need the material index, which would be the E material index. T dot x position would be E origin plus E sprite offset dot x and dot x here too, like so. Don't forget the semicolon. Do the same thing for the y position, only change x to y, and then t dot size x and size y. They are meant to be the size of the texture. So we get the texture size. Get texture size based on the M asset type ID. And then we set in the size x to texture size dot x semicolon and texture size dot y semicolon 2. Quickly check if that builds. Did I forget anything? Get texture size, not all control paths return a value. I guess I forgot something. Yeah, I didn't. Let's create a vec2 here. Size is initialized to 0 and then we set the vector and then return. Try that again. Let's see if that runs. Apart from my left pedal not showing up and the ball seemingly penetrating more than half, it looks okay. I guess I didn't place the left pedal properly. Lol. Okay, I found the first issue. It's the clamp function. We are not supposed to clamp the origin itself, but only 0 plus half the bounding box size on the top part. That made the pedal go off screen very quickly. I found the next problem too for the ball. When it penetrates on X, it's actually penetrating with the origin being a positive value still. And therefore we can just invert the X position, because that would turn it into negative mode. We need to remove the penetration. And that would be 2 times. Because we are, removing the penetration and then we are extruding. We penetrate it like this. We need to do the same thing for Y as well. Build and run. And that looks good too. Very nice. I'm gonna quickly add in some Y velocity again, to make sure everything is feature parity. The pedal cannot go outside the screen. And the ball can't either. Very good. Now we restructured our program to handle origin. If you like what I do, consider tuning into my Twitch. I stream at 10 AM Central Eastern Time, which is 1 AM Pacific Daytime. If you want to directly support me, you can do so via Patreon. This will give me more time to work on my game Cakes to D. And you will get reading access to the GitHub repository. Patreons will also be called out at the end of every video. Subscribing and leaving a like also helps a lot. Thank you very much for your support. So thank you to Felix F and Meo the Writer for being the first supporters on Patreon.